Chapter 13, Abstract Classes and Interfaces, Part 2. This is the last video, absolutely worthy of a yes, or maybe better yet, of a let's go. Let's jump right in and knock this one out. Interfaces where we are at. Let's first, though, back up and remind ourselves of the last video, abstract classes. What is an abstract class? An abstract class we would define as usually being a class that has one or more abstract methods, which, as you remember, is a method that has no implementation. It's basically just that method signature with, or that method header with a semicolon, no implementation whatsoever. Of course, we can also have abstract classes that have no abstract methods, in which case, why did we even make that class abstract? And the answer is because we don't want to allow to make instances or to try to instantiate objects of that particular class, therefore we make it abstract. That's an abstract class. What's the connection? Because this chapter is called Abstract Classes and Interfaces, so there is a connection between the two. An interface is a class-like construct, which has it resembles in a way portions of an abstract class in that they both contain or may contain abstract methods. So an interface is this class-like construct that allows us to define common operations for objects. An interface will only contain abstract methods. An interface cannot contain concrete methods, which are methods that have implementation. That's not allowed. Whereas in an abstract class, you can have methods with an implementation. You can also have methods that are abstract. In an interface, you can only have abstract methods, period. You can also only have static variables. Remember, what is a static variable? It's a variable that belongs to the class, or in this case, belongs to the interface. The only variables allowed are static variables that belong to the interface. And that should make sense, because since we cannot instantiate objects of an interface in the same way we cannot instantiate objects of an abstract class, you therefore won't have any instance variables. That should make sense, right? If you can't instantiate objects or instances, there will be no instance variables. We will only have static variables. An interface is similar to an abstract class, but the intent is different. The intent of an interface is to specify common behavior for objects of either related classes or unrelated classes. And the common behavior that's often shown in textbooks is a strange common behavior, if I'm going to be honest. But the example used is edible. Is something edible? Can it be eaten? And we'll go over an example with this. But you could check if two objects are comparable, clonable, edible, and so on. An abstract class may have one or more methods that need implementation because those methods are abstract. An interface consists exclusively of methods that need implementation. You cannot have any method with an implementation. Now, to distinguish an interface from a class, Java uses the following syntax, where instead of saying public class and then the name of the class, we now have public edible and then the name of the interface. And as I looked down, I realized I said public edible. We have public interface, and then the name of the interface. Using this example, it will be edible. And this interface here has only one method in it. That method is called how to eat. Of course, this method is an abstract method, right? Because every method that is part of an interface must be abstract. So instead of having the word class, we have the word interface. So some more details. As I mentioned, an interface is treated almost like a special kind of a class. In fact, each interface file is saved inside a Java file and is ultimately translated or compiled into its own separate bytecode file, just like you have with classes. So it's very similar. You can use an interface in pretty much the same way you would use an abstract class. You can use an interface as a data type for reference variables. You can use an interface as a result of casting and more. Also, as with an abstract class, you cannot create instances or objects from an interface using the new operator. So some reflection questions. What is an interface? Why is an interface useful? So what is an interface? Well, he told me an interface, basically it's similar to a class, but it doesn't say the word class, it says the word interface, and it can only have abstract methods and static variables. Okay, that's an interface. Why is it useful? How do you define it? As already shown, you define it by using the word interface there. And then how do you or when would we want to use an interface? The best way to answer these questions is absolutely with an example. So let's jump right over to NetBeans. And I have this, how many files do we have here? 1, 2, 3, 4, 5, 6, 7, 8 files. And we're going to look at each one in a particular order. The main, which is interface demo right here, we're going to look at last. I'm going to start with the actual interface. So here is the interface. Let me make sure we're zoomed in plenty so you can see it. Public interface editable. Remember, if this were a class, it would have said public class editable. But it's not a class, it is an interface. Now, why is that even showing an error right now? Well, because I could make this a class, but the error is simply because I have an abstract method. So if this is a class, I would have had to have put abstract right here. But again, this is not a class, this is an interface. And an interface is similar to a class, similar to an abstract class in particular, and an interface will only have abstract methods, meaning I could not come right here and say public void do something and make that method. It's not allowed. What is the actual error message? Interface abstract methods cannot have body. Yes, this method, it's assuming it's an abstract method, and then it says, hey, it can't have a body. And I need to come up here and type the word abstract. Okay, so we have this interface editable. This interface editable has a singular method inside of it. It's an abstract method, of course. That singular method is called how to eat. It merely returns a string telling you how you can eat a particular thing. What are the things? Well, we're going to look at apple, chicken, fruit, and orange, and we'll see how to eat those things. It's a silly example, but it demonstrates or illustrates for you how interfaces work. So this one interface, it looks like a class. It has a singular abstract method, how to eat. And one more time, as I said, because it's very similar to an abstract class, I could have called this abstract class. I could have done that, and it would have worked similarly, but there's some advantages to using an interface, which I'm going to go over. So here's our interface with the one abstract method, how to eat. Let's look at now fruit. Fruit is the superclass of apple and orange, which I'm going to show you in a minute. Fruit is the superclass. Notice inside fruit, other than these comments, I can get rid of those comments briefly. Other than the comments, we literally have nothing inside fruit. No constructors that are visible. Of course, there's a default constructor. We have nothing inside fruit. And you might say, well, then what the heck is the purpose of fruit? If there's nothing inside of it, why do we even need it? Well, because we have these two classes, apple and orange, which they're both types of fruit. So yeah, you may as well make that parent class, that superclass fruit. And then apple and orange will extend fruit. Now, we also see fruit, it implements edible. What does that mean? This is the first time we're seeing that. As opposed to, we would normally see extends, right? Apple extends fruit. What does extends mean? Extends mean that you are inheriting from fruit. You're inheriting all of the accessible methods and all of the accessible data members. What's going on here with fruit is we say public or abstract class fruit implements edible. What does implements edible mean? It means, and it's actually called an interface inheritance, which is pretty much like inheritance. When you implement edible, that means that you will inherit all of the methods that are accessible in edible. And what is the method? It's right here, this public abstract string, how to eat. So right here, when fruit implements edible, it basically does this. It inherits, sorry, let me put this back. It inherits this method right here. This method has now been inherited. And we could here, since it's being inherited, it's saying add the override notation. Now, I'm not going to explicitly put that in my code. There's no need to put that in my code because we're already inheriting that method. And we're not going to provide an implementation. We're not going to provide the implementation because we don't know how to eat a generic fruit. We know how to eat an apple. We know how to eat an orange, but we don't know how to eat necessarily every kind of fruit in the exact same way. So I'm not going to put an implementation for this how to eat method, which again, it came from where? It came from the interface edible. But fruit is implementing edible, which means that fruit is going to do what? Fruit is going to inherit this how to eat method. But when fruit inherits that method, we told you before, with inheritance, you have a choice. You either have to, with an abstract method, when you inherit an abstract method, you either have to implement that method, provide an implementation for that method, or you in turn, this is option 2, you in turn have to be abstract. So imagine if we did not have this abstract instead of in front of the word class. And right here, we say that I would like to, and what is the error up here? Saying abstract? Yeah. So, and right here, I say I would like to, it's going to inherit this how to eat method, and I need to provide an implementation to it. So I'm just going to say, oh my gosh, here, let me paste all of this again. Everything's out of whack. Paste over. Get rid of this. Here, get rid of the word abstract. And here I can just type return some string. Now Java's happy. Java says, hey, this is just a class fruit. You're implementing edible, which means that we are inheriting this how to eat abstract method from edible. And when you inherit it, you have got to provide an implementation to that method if you don't want to yourself be abstract up here. Now, we're not going to provide an implementation for the how to eat method inside fruit because it doesn't make sense. There's different ways to eat different types of fruit. So I'm not going to provide an implementation here in the fruit class. I am inheriting this abstract method, but I am not going to provide an implementation. Sorry, I'm inheriting this method, but I am not going to provide an implementation for it right here. Instead, I'm going to delete that, and I'm going to therefore have to do option 2, which is to make this an abstract class. So this is what this says. Fruit has no data members. It's really just a superclass of apple and orange. Fruit implements edible. This means that it does inherit that how to eat method. We are not providing an implementation of that method. Instead, we are saying this fruit class is abstract. And now any class that extends fruit will have to provide their implementation of that method. Because even though we don't see it, what do we have right here on line 9? We really have this unimplemented method right here that was inherited, and we did not provide an implementation to that. So it's sitting there. It's been inherited, and it's waiting for an implementation. So any subclass, which I'm going to come to apple right now, any subclass of fruit that extends fruit has got to provide an implementation of that how to eat method. And here we are. Apple extends fruit. It's just a regular class. It is extending fruit, which means it inherits any and all public accessible methods as well as data members. Well, what public methods are here in fruit? You might say, well, I don't see any. Well, you don't, but fruit implements edible, which means this public method, which was inherited by fruit, in turn got inherited by apple. So it was inherited right here. We have the override. It was inherited, and it was abstract. But we've said, you know what? We're not going to make it abstract. We're going to provide an implementation, so we do so. And here's the implementation. The implementation given on this silly little teaching example of how to eat an apple, it says, return this string, apple, make apple cider. So apple extends fruit. Fruit has no data members as we saw, so there's nothing to inherit on the surface. But since fruit implements edible, all subclasses of fruit must also implement edible, which means this apple subclass must provide an implementation of the how to eat method, which it did. Orange is the same thing. Orange extends fruit. And we therefore have inherited this how to eat method, not directly from the fruit class, but in fact, it went all the way back and it came once again from this edible class. We had this edible interface. We had this abstract how to eat method. It was inherited by fruit. And then we are extending fruit right here in orange, and we are finally providing an implementation of that how to eat method. Hope that's clear. Let's come on now to animal. We have public class animal. Just a basic, I said public. We have abstract class animal. Just a basic class. It's abstract because it has an abstract method. What is this abstract method? It's called sound. We want to return the sound that a particular animal makes. Of course, it makes sense that this method should be abstract because I don't want to implement this method sound right here and say, okay, we'll return some sound because different types of animals make different sounds. So it makes sense that this animal class will be, in fact, it makes sense that this animal class will in fact be abstract, and this sound method will be abstract as well, meaning that any subclasses of animal will provide their own unique implementation of this sound method. Let's come over here to tiger. Class tiger extends animal. We are overriding that sound method that has been inherited, and we're saying, yes, the tiger says roar, and that's what we are returning. That one's pretty straightforward because that's just using inheritance. We've already seen that. Chicken is the one that really brings it all together. Check this out. Class chicken extends animal, just like tiger extends animal, which means what? Remember, the tiger extended animal, which meant that the tiger had to provide an implementation of this sound method. So the tiger provided the implementation saying tiger roar, right? Sound roar. Well, in that same way, chicken is going to extend animal. So chicken must, by virtue of extending animal, it must provide an implementation to this abstract sound method that returns a string. Sure enough, here's that implementation provided. It says chicken says cock-a-doodle-doo. But what else is going on? Here we say that chicken implements edible, which means that chicken also will inherit all of the accessible methods from edible, which is what this how to eat method, because chicken, we can eat it. So therefore, because it has inherited this how to eat method, we need to provide that implementation. And so therefore we have return chicken, you fry it. There's many other ways to eat chicken, just a silly example. So we've covered the interface, the edible interface. We've covered fruit, apple and orange, the subclasses of fruit, and fruit merely implemented edible. That's it. We covered animal, which had this string, this sound method returning a string, which was abstract. And then we covered chicken and tiger, their respective sounds that they make, and the fact that chicken was also edible. So we had the chicken class implement edible and show one way of eating a chicken. Finally, we come back to the interface demo. Here's the demo I made. Line 3 might be the first time we've seen something like this. I said, let's make this array called objects of type object. Polymorphism, right? I'm saving all of these references all into an array of the most vanilla type, which is object. That's the highest level in that hierarchy, the highest superclass, the most generic. And inside this array, how many items do I have? I have 4 things. Each one of these things is a reference to a particular object. Here's a reference to a tiger object. I'm making a new chicken object, a new apple object, and a new orange object. I just did that on the fly. Of course, I could have come up here and said tiger T equals new tiger. Chicken C equals new chicken. I could have done this for each one. And then here I could have just put T, and here I could have put C, right? That's fine. But there's no need for this teaching example to do it that way. So I made a new array. Within that array on the right side, I went ahead and just made 4 new objects. and the references of those objects got saved right there and ultimately got saved into this array called objects of the most vanilla supertype. I then looped over the length of that array, and I'm going to print one of two things. I'm checking first if that particular object is an instance of edible. So notice, in the same way we can check is it an instance of a class, we can check if it is an instance of an interface. Very important. So if this particular object is an instance of this interface, edible, we want to print how you eat that particular object. So we're going to print how you eat. Is tiger an instance of edible? Nope. So we won't print how to eat a tiger. But we will print how to eat a chicken because it's an instance of edible. We will print how to eat an apple as well as an orange. So we're going to print those things as well. And then the second part of the for loop, we're checking if this object is an instance of animal. If it is, specifically, we want to print the sounds that it makes. Let me hit run, display this output. So we go through, we have come to tiger. Tiger is not an instance of edible. Tiger is an instance of animal. So we're going to print the sound of a tiger, which is roar. Chicken. Chicken is an instance of edible. So we're going to convert it to edible. Notice how we even cast it to the interface data type. As I said earlier, we can use an interface as a data type. So we're casting this vanilla object to a data type of edible so we can call the how to eat method, and we say chicken, fry it. Also, is chicken an instance of animal? It is. Print the chicken sound, cock-a-doodle-doo. We're at apple. Is apple an instance of edible? It is. Print how to eat an apple, make apple cider. Orange is the final one, or let me finish with apple. Apple is not an instance of animal, so nothing happens there. We're in the final object, the final iteration of the for loop. We're at orange. Is orange an instance of edible? It is. So we cast that vanilla object to data type edible. We call the how to eat method, and it prints make orange juice. Finally, orange is not an instance of animal, and therefore we don't execute that code inside the if statement on line 12, and we are done with this example. So I would recommend, if need be, backing up, watching that again. I hope you coded all of this. I'll try to remind you to code all of this as you go through it. Make sure you're really comfortable with interface, with implements, with checking is it an instance of an interface, casting it to that interface type, and be comfortable with this. Let's come back to the slides. So we looked at this edible.java interface, and we can use that interface to specify whether an object is edible, and we can accomplish this by using the implements keyword to say that this particular class is implementing the edible interface. Fruit implemented the edible interface. Chicken implemented that edible interface. The relationship between the class and the interface is known as interface inheritance, and I mentioned that already. But because interface inheritance and class inheritance are effectively the same, we're just going to call them both inheritance. But you inherit from an interface in the same way that you inherit from a class. So let's look at some of this here. We see that fruit is a supertype of apple and orange. Clearly, animal is a supertype of chicken and tiger, but even edible is a supertype of chicken as well as fruit. Edible is a supertype here. The interface and its methods are italicized, and the dashed line and the hollow triangle are used to point to the interface. What's important to know is we don't need to actually put these public static, final, or public abstract modifiers inside an interface. You can actually omit them. Why can you omit them? Because all data fields in an interface must be public, final, static. All methods in an interface must be abstract, period. As a result, Java's like, you know what? If you don't want to type the word abstract, I got you, because it knows it's already abstract. Java says you don't want to type public static, public final static. No problem, because it already knows that every single data member must be public final static, so it doesn't force you to do that. A page summarizing the differences between interfaces and abstract classes. A class can implement multiple interfaces. That's the first time I've said this. That's very important. That's one of the reasons why interfaces are used. Because in Java, a class is only allowed to extend one superclass. So a given class can only extend one superclass. But there's going to be instances where you really want to extend a little bit of this, a little bit of that. You want to make a subclass that really inherits from many things and not all up that same chain. How can you accomplish that in Java? Interfaces. You extend one class, which means you inherit from that class, but you also implement several other interfaces, which means you're going to, in fact, inherit from those as well. In an interface, the data must be constants. We've covered that. Whereas in an abstract class, you can have any types of data. Also, each method in an interface must be abstract, a signature with no implementation, whereas an abstract class, you may have abstract methods. You can also have concrete methods, methods that have implementation. Also, a constructor. Abstract classes do require constructors, even though we do not instantiate objects from abstract classes, but we need to have that constructor when we are creating objects of the subclasses to help us build those objects. That's not the case for interfaces. There are no constructors. An interface cannot be instantiated using the new keyword. Do you use an interface or do you use a class? So some final points for consideration. They can both be used to model certain features. How do you determine should you go one route or another? The general answer is, if you have a strong is-a relationship between two classes, and it's like more of that parent-child relationship, the person-student, the employee-staff member, for example, that is when you want to use inheritance. When you have a weak is-a relationship, known as is kinda a relationship, where an object maybe possesses a certain property, like it possesses the property of being edible, that's when you would use an interface. Those are the two general answers. When you have a strong is-a parent-child relationship, inheritance, a weaker relationship, interface. But that's not the end of the story. Because the other part of the story is, as I already mentioned, that the other value of interfaces is to circumvent single inheritance, that restriction that Java gives you where we can only inherit from one superclass. When you want to inherit from multiple classes, which is called multiple inheritance, what you do is you make one superclass, because you can only inherit from one superclass in Java, but the other superclasses that you would have inherited from, you implement them as interfaces. And guess what? We are almost done. I say 6 pages, it's not even 6. I think it's 4 more pages and we are completely done. These 4 pages are merely summarizing some of this OOP design that we've covered over the last 6 and 7 weeks. A class should describe a single entity. And all of the operations of that class, they should fit logically together. They should have a coherent purpose and theme. You can use a class for students, for example, but you should not combine students and staff in the same class because those are different entities. So you should make a separate class for student and a separate class for employee, and then a subclass for even faculty and for staff. A single entity with many responsibilities should be broken into subclasses to separate and distinguish those responsibilities. You want to have a good, consistent design with your OOP. Follow the Java standard programming styles and naming conventions. Have informative names, we've covered this. Those names should be for classes, for data fields and methods. Don't call everything X, Y, and Z. Give meaningful names. A popular style is to place the data declaration before the constructors, right? You put your data members up top, then you put your constructors, then your getters and setters, and then the other methods of the class. Encapsulation. Everything should be private unless there's an argument to not make it private. Provide getters and setters, only, or getters in this case, only if you want the data field to be able to be read, and setters if you want it to be able to be mutated or modified. All of these things, cohesion, consistency, encapsulation, the value is they help you get clarity with your OOP and with this designing that you're trying to come up with OOP. In addition, a class should have this clear contract, meaning in that the contract of that class and all the headers of the methods to explain and to make it easy to explain and easy to understand. Completeness. Classes are designed for use by many different customers. In order to be useful in a wide range of applications, a class should provide a variety of ways for customization through properties, through methods, accessible as public methods for the end user. An example given here was the string class. The string class has over 40 different methods that are useful for so many different applications. We've maybe only used a handful of those string methods. Instance versus static. We've covered this exhaustively. Know the difference. A variable or method that is dependent on a specific instance of the class should be an instance method. A variable that is shared by all instances of the class and owned by the blueprint, that is a static variable. Always reference your static variables and methods from a class name to improve readability and to improve or to avoid errors. Do not use an instance variable to then reference a static data member. That doesn't make sense. We should use the class name. Do not pass a parameter from a constructor to initialize a static data field. That makes no sense. If a static data field, a static data member, which belongs to the class, you're not going to initialize that when you build a constructor, when you're constructing a particular object or an instance of that class. That doesn't make sense. Finally, it's better to use a setter method to change a static data field. Last page. Abstract classes and interfaces are very similar. They can both be used to model a similar type of a problem. How do we choose which one is better for us? It's based off of that strong is a relationship versus that weak is a relationship that we've already covered. And guess what? We are now done. That was the last slide. I have 6 great gifts to get all of that emotion out there. Let me put my let's go on the screen. I love this one. Come on, Fresh Prince. Come on, it's always a win, Fresh Prince. I feel that. Yeah, I feel that one a lot. I don't know about that one, but I thought it was funny. Yeah, come on, you got to throw in Thor and just another let's go. It has been fun. Think about how much you all have grown. Think about how much you've grown over the course of watching these videos, solving all of these problems over the entire semester and where you've come from. You've grown a lot. You should definitely pat yourselves on the back and be proud of what you've accomplished. We've gone through the basics of Java. We're talking about, your basic Java syntax, selection statements, loops, methods, arrays, array lists. Then we get into OOP with array lists, objects, classes. Did that for 3 weeks. Inheritance for 2 weeks. Then we did exception handling, abstract classes, and interfaces. It has been fun. Signing out. Everyone, as always, feel free, leave a question or comment if you need anything. Take care.